So, yeah. So, good evening, everyone. I want to apologize for yesterday's, you know, situation. Right. So, we had to see how we could complete what we dealt with in lesson 5. There was a very important part that we did not touch on. I want to believe my screen is visible. Yes. So there was an aspect we did not touch on completely, and that is manipulating string in R. So I thought we should look at that before moving ahead to other stuff, which is modeling. All right. So in here, we are looking at this particular, we're bringing on this package called string R. It's a package for manipulating string. It has all kinds of functions there. Remember, I told you how to check out a package. You can either come here and go to the package site, type the package name here, string R. It's already here. Good. This is it. You just click on the package, and that will open up. So whatever it is that you can do with string, just look through. Some of the things we're going to be saying here, they are all here. So this is the best way of learning R, in my opinion, through packages. If you are patient anyways. So when you see anything, you go back and test it out. So let's see the few ones that we have here as time will permit us. So consider, after loading this, let's load the package first and foremost. So consider this string. Let's do some manipulation in this string. So if you're using this function in this package called string sub, it is for substringing, it is for subsetting string. So we want a part of this string. All right. And this part of this string, this argument you're giving here means that where you want the subsetting to start, here is starting at the 13th letter. In this case, even a space considered as a, as a character here. So the 13th character here, and then end it at the 20th character. Let's run this and see what comes out. It brings out a definite. So this is the 13th character, and this is the 20th character. All right. So another function is string locate. Let's remove this all for now. String locate. So what this does is that it locates the first position where you find E in what you are passing into it. If it's a vector of strings, this is a single string now. It is a single string. If it were to be a vector of string where you have a C in front, and then you have comma, another string, comma, another string, all right, then it is going to look for the first place E appears in this first string, the first place where E appears here, and that's what this is going to return. But in this case, it's only one string, so it's going to return E coming up so this string is the first string, and it's going to return E in position number 2. So let's run this and see what comes out. So it's telling us that E is occurring in the first string, position number 2. That's where E is occurring. And then it just ends it there. It ends it there. But if you are going further to look for where all the places where E occurred in this string, so you use this particular function. You run this now, just imagine. It's telling us that E occurs, the first place E occurs is the second position. E also occurred in the 15th position, and E occurred at the 20th position, as you can see. All right. So that is that about this particular function. There are other ones, replace. So str replace. What do you want to replace? Where is the thing? All right, and then the replacement itself. As simple as that. All right, so let's even try this. So let's say we are replacing this. Let's say we are replacing this. All right, let's put it in in quote, and then we are replacing with hello dear. Okay, let it be dear. Let it be dear. Hello dear Adekunle. All right, let's see if this works. Good. So the answer comes out. Hello dear Adekunle. So word is replaced with dear. See that? So this is self-explanatory. You are replacing you are converting to lowercase. All right. You are converting here to uppercase, whatever letter you pass to it. Let's do that for this. Everything becomes Adekunle. All right, lowercase, and you can do for upper as well. Everything becomes Adekunle uppercase. So this string manipulation is very necessary. So you can do a whole lot of things here, okay? So this one has to do with padding. If you want some spaces before, so string padding. So if you want some, let's say you want 20 spaces to the left before Adekunle, before the string, you come here, you know. Is this one really, is this working? Side, yeah, it's supposed to be. Let's see another example here. String pad. Let's do for I. Okay, look at it. There's a space. Look at the entire space before I. All right. So there is a whole lot of space. 10. I don't know why the one of Adekunle is not working. Where is it again? Up here. Where did we see the pad? Okay. So it's supposed to work. Anyway, if it doesn't work, we'll move on. All right. I don't know why that's not working. We saw the one that worked. So that is how that is as far as this is concerned. So we are going to move ahead right now. Something very important, and that has to do with linear regression. Regression, all right? Regression. So for linear regression here, I'm going to Hello. Hello. Can you hear me now? Am I audible now? Hello? 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 Okay, just confirm once again if I'm audible. Can you hear me now? Okay, okay, thank you very much. So one more thing, confirm if you can hear the sound
There's an X
coming from the video.
variable and a Y variable in this case.
Can you hear the
The independent variable is on the x-axis and the dependent variable is on the y-axis.
Can you hear the sound from the audio from the video?
And we try to form a relationship between these two variables and draw a line, in this case a straight line.
Oh, great.
And over the next series of videos, I'll explain what all this means. This tutorial is an introduction to regression. There's an x variable and a y variable in this case. The independent variable is on the x-axis and the dependent variable is on the y-axis. And we try to form a relationship between these two variables and draw a line, in this case a straight line. And over the next series of videos, I'll explain what all this means. What we try to understand is as the independent variable is moving or changing, what happens to the dependent variable? Does it go up or does it go down? How does it change? If they move in the same direction, if the independent variable increases and the dependent variable increases as well, like this, we say there's a positive relationship. If, on the other hand, as the independent variable increases and the dependent variable decreases, like this, we say there's a negative relationship. The line would look like this, go downward. In linear regression, we try to make a line to make a linear regression. The key is on line right there, a straight line. You can also do curved lines, but for this topic, it's all straight lines. To actually conduct regression, I take observations, and I'll just plot some more observations in here randomly. I'll stick them in here like that. And I try to find a line that will fit, a straight line that fits through all these different points. And this is called my regression line. And it's based upon the least squares method. And in the end, I want to minimize the difference between the estimated value and the actual value. I want to minimize my errors. This line will have a lot of errors if I compare the actual to the estimated value. And again, the point is to minimize these errors or make them as small as possible. Now let's imagine I put study time on the x-axis, or make that my independent variable, and the dependent variable becomes grades or GPA. As study time increases, grades should go up. There is a positive relationship. In regression, we develop these equations like this. In this case, y hat is estimated grades, and it's based upon, or it's equal to, b0 plus b1 times x, where x is study time. b0 we derive mathematically, and it is the y-intercept. b1 we also derive mathematically, and I'll do it in a later video, and it's the slope of the line. In this case, the slope is positive. In the next video, I'll discuss how you develop these equations. Now, if I change the x-axis to time on Facebook, we see a negative relationship. More time on Facebook, grades will suffer and go down. A negative relationship. What we're estimating is still grades, estimated grades. is equal to b naught minus b1 times x, where x is time on Facebook. B naught is still the y-intercept. The y-intercept. And it is a calculated value. The slope of the line is negative b1 because it's downward sloping, negative relationship. And as I said before, I'll show you how to calculate this equation in the next video. The x is the independent variable. The y is the dependent variable. The x is what we control, what we manipulate, what we change. And the dependent variable is the outcome. So study time is the independent variable. It's what we control and manipulate. And your grades are dependent upon how much you study. Now this looks really ugly, and it's what I'll talk about in the next video. But I'll step you step by step through it and hopefully make it simple for you. This tutorial is an
audio thing happening again. Can you guys hear me? Uh, okay, you can hear me now. Thank you very much. So if you run this, the model is run, all right? Just run the model. So if you want to see what is in the model, you can just highlight the model and run it. See everything about the model. Here you see. Of course, two things will come out from the model, the intercept and the weight. When the weight is negative, which is the independent variable, that should tell you that it has a negative what? Negative relationship. As you could see there from the plot earlier on, it has a negative relationship. All right. So it's just as simple as this. All right. So you look at your data, you see, okay, the first thing you want to do is that you want to plot the different aspects of the data. How are they relating? You can even do that. You're using your correlation plot, where you plot all of the different columns against each other. We have done that before, and then you'll be able to know what relationship exists between them. But for a linear model of this case, we are just modeling a single dependent variable, against another. I mean, of course, the dependent variable will always be one. So a dependent variable against one independent variable. All right, that's a simple linear regression. But you can have multiple linear regression whereby you are modeling a dependent variable to uh, 2, 3, 4, 5, 6, and many more independent variables. All right. If we have time, we're going to explore an example in this manner, hopefully. All right. So let's see. I think we still have a few. Okay, we still have about 5 more minutes before we start the meeting again. Okay. So let's just check a few things about this model. Let's check a few things about this model. The first thing we want to do very quickly is to fit a line. Let's fit a line. Let's fit a line on this model. So we're going to fit a line on the model itself. Can you see that? So we just fit a line on the model and look at what it brings us. So this is the model line. We added this model, which is this line, on the initial plot that we have. And as you can see, where this line is passing is, let me refresh that. That is the best fitting line. Okay. Now you see that the depth runs at around 37 depth. Okay. So this is the best fitting line, as you can see. If I have to blow this up, you see it, comes. I'm not sure if this blown map is showing there. All right. So there are a few other parameters that you'll be able to see. But after coming, let's go on this short break. We'll come back and continue because of it. All right. So please just connect back. I'll end the meeting now. Connect back immediately so that we can continue.